right, hello physics students. Today we are going to be just doing another example problem about conservation of momentum. In the last example we saw a collision in which two objects stuck together and started to move as one. And I'm just going to present a situation in where two objects can bounce off of each other and move independently. And that's what happens in a lot of collisions. But here we have a big truck crash into a smaller vehicle. Here the situation before, our big truck's mass is 3,000 kilograms and it's moving at 10 meters per second. This smaller vehicle's mass is 1,000 and it has a velocity of 0. After the collision, we are told that the car is moving with a velocity of 15 meters per second in that direction, and we want to know what the heck this truck is doing after the collision. And so we're going to figure that out. So remember, the key thing again is that the total momentum before, just like the money example, right, equals the total momentum afterward. So if I have 50,000 momentum units, I should have 50,000 momentum units over there. And I have just a streamlined way again of setting these problems up so you'll never get them wrong. All right, so first things first, I need to figure out how much momentum I have to start. So we have 3,000. Remember, our formula for momentum is mass times velocity. 3,000 times 10 is 30,000. So we have 30,000 kg times meters over seconds. Our momentum here, anytime we have a velocity of 0, we're going to have a 0 momentum. So 0 kg meters over seconds. All right. So over here, I have a total of 30,000 plus 0. And we're going to set it equal to the momentum on this side, or the equation on that side. So here our momentum is 3,000 times our velocity. Okay? Because we don't know this velocity, so we're just going to leave it as this. So we'll call this momentum 1. Momentum 2 over here, momentum 2, we have 1,000 kilograms is the mass of the vehicle, and its velocity is 15. So I have a total momentum, 1,000 times 15, of 15,000. So 15,000 kilograms meters per second. All right. So now we need to add these two up. So we have 3,000 V plus 15,000. All right. Sweet. And we've already set this equal to this. So our equation, and let me rewrite this over here, we have 30,000 equals 3,000 V plus 15,000. Many of you have done problems like this in algebra. We have to subtract 15,000 from each side. And we're left with 15,000 equals 3,000 V. To get velocity by itself, we divide by 3,000. And we end up with an answer of 5 meters per second. All right. So again, the big key thing, what we did, we found the momentum of each individual object before the collision and after the collision. We added up all the momentums before the collision. We added up all the momentums after the collision. And if we didn't know a variable, if we didn't know mass, if we didn't know velocity, we would just write it as a variable. And when we add everything together, it creates an equation for us. And that's the thing with physics equations, is we don't always have just a set equation, but it's a guide to think. And how we set up the problem is most of the work. And after we set up the problem, it's just a straightforward algebra problem. If you struggle with algebra, if you struggle with math, no worries, come talk to me and I'll help work through that with you. That's my job. I'm happy to help you. So just let me know, communicate with me, and I will help you learn this. Thanks for watching. I'm going to do one other example of just kind of a tricky difference when we have an object moving to the left, how we handle that. So stay tuned for that in this next video. I'll keep it pretty brief. Thanks for watching. We'll see you next time.